Okay, section 5.1, problem number 4. There's quite a lot involved in this problem, so as we go through, I will point out quite a bit of information for this. The first thing, though, it's asking you to do is to find all the real zeros, and you're going to look at this part right here to find the zeros. Now let's move on down to where I've actually worked the problem. This is your original problem. You're looking at this part right here. These non-constant factors here will turn into zeros. So you would have a 0 at x equals 7 and x equals -6. Of course, -6 becomes a double 0. It's a little background information here. This is kind of like the factors you have. M stands for the multiplicity. If this M is an even number, the graph will just touch the x-axis. If the M is an odd number, the graph will cross the x-axis. So you found your two zeros, 7 and -6. They're referred to as the larger and the smaller. Of course, any positive number is going to be larger than any negative number. So the multiplicity of the larger one, 0 being 7, its multiplicity, its exponent is non-existent, so since it's not there, it's understood to be 1. For the -6, the factor that produced that -6 has an exponent of 2, so its multiplicity is 2. So now what happens? Does the graph cross or touch at each of the zeros? Know what that was. Okay, the graph crosses the x-axis at the larger 0. Why is that? Because the multiplicity of the larger 0 was an odd number. It was 1, so it crosses. The graph touches the x-axis at the smaller 0, so the -6, the exponent was a 2, therefore it touches. This is a little chart that gives some information. The sign of the leading coefficient, if it's positive, an odd degree, it starts low, ends high. If it's negative an odd degree, it starts high and ends low. If it's an even degree and the leading coefficient is positive, it starts high and ends high. If it's even with a negative lead coefficient, starts low and ends low. The number of turning points, which is what this is really after right at this moment, is n, which represents the highest exponent, -1. That's the maximum number of turning points. So in this particular problem, if you take the important pieces here, which were the x -7 and the x plus 6, think about it if you were to multiply that completely together. What really ends up happening is your power would become a 3 because you would end up with an x cubed because you had an x and an x squared term, which gives you an x cubed. Since that is a cube, n equals 3. So your highest power is a 3. Your maximum number of turning points is going to be 1 less than that. So 3 minus 1, of course, is 2. The power function that resembles the greatest value of x. This is referring to what the lead term would be if you were to multiply it completely together. You really don't have to multiply it together. You just kind of have to come up with what that lead term is going to be. So we had already come up with the x cubed part, then we would distribute the constant of -6 by it. And so it would look like -6x cubed is what that particular part would look like. I hope this makes sense.